Okay, so we're starting off with trigonometry here. And what special word is hidden in here? There's a couple of ideas here. There's the tri and the gonometry. And gonometry sounds like geometry, right? Gonometry. So the idea is this is the study of three-sided shapes. So we're looking at three-sided shapes. What about four-sided shapes? What about five-sided? You know what? Sure, we can look at that later, but we start with our basic three-sided shapes. And you can think, how many sides do I need to make a shape? Well, if I have one line, not really a nice shape. If I have two lines, still not an object, right? And then if I have three, we have something now. So the most primitive object we can talk about here is this three-sided shape. And one of the things that we talk about is that each of these three sides are completely related to each other. It's almost like three members of a family, a mama, a papa, and you. If your dad's pissed, it changes both your lives. If your mom's pissed, it changes both your lives. Remember, if the mom ain't happy, no one's happy. And if you're annoying, it doesn't bother your parents. I'm just kidding. Everyone changes. The sides are affected, the angles are affected, everything is in the triangle is affected. A couple of characteristics we have about these triangles is that they all have three sides, duh. And they also have three angles. And the cool thing is that anytime I affect one part, whether it's a side or angle, it affects many other parts. You can't just change the side without affecting angles, and you can't affect an angle without affecting sides. So everything is affected. So there's this ecosystem of balance here. And the cool thing is that all this stuff is predictable, right? You've heard of that stupid saying where, if a butterfly flaps its wings in Asia, it causes a tsunami in Florida. Not really, but sure. So the same idea happens here, except it's all predictable. If I change an angle, what happens to the corresponding sides? What happens to the side, its opposite side? If I change the side, what happens to its angles? So one of the best ways to start talking about these relationships is what we call the Pythagorean Theorem. Pythagorean Theorem. And the Pythagorean Theorem states that for any right triangle, so if this triangle is a right triangle, so if this is a right triangle, and we draw a little triangle shape, if right triangle, then this statement must be true. A squared plus B squared equals to C squared, where A and B are considered the legs, a leg and a leg, and the C is the hypotenuse. Let's illustrate that in just a moment. But, okay, let's illustrate it. Here we go. We have a right triangle, and we're labeling the sides as legs, a leg, and a leg, and this is hypotenuse. Please don't think of the hypotenuse as just the slanted side. The hypotenuse is always a side opposite, this is opposite, OPP, opposite of the right angle. Sometimes kids find it a little better if I illustrate it like this, where's the hypotenuse? Look, the right angle's pointing at it. Here I am. It's literally pointing an angle, a little pointer. I'm over here. If I spin this around, and this is my right angle, where's the hypotenuse? Well, here I am. If I write it in any particular way, if this is a right angle, here I am. So it's not the slanted side, it's always the side that's opposite of the right angle. So no matter how we spin these triangles, the hypotenuse is always the opposite side of my right angle. And that's an important thing to take away. Now the legs, nobody cares. Your left leg, your right leg, nobody cares which leg is which. So the A and B can be reversible, but the C value must be concrete, okay? Now, what happens is, this is what we call an if and only if type of theorem. if this is a triangle, then a squared plus b squared equals c squared. It also works the other way. If I told you the relationship of the sides of a triangle are a squared plus b squared equals to c squared, then you must know that this is a right triangle. Then let me write this in a different way. Then triangle is right. So we can decide if a triangle is right if I don't know any of the angles. Now if I give you a side of a triangle that says 3, 4, and 5, and I don't specifically label that this is a right triangle, can I prove that it's a right triangle? And if I prove that it's a right triangle, I can bring in all the characteristics of right triangles. So let's go ahead and prove that this is a right triangle first. One thing that we want to know is that the biggest side is always the hypotenuse side for us. And I'll explain that in just a moment. So the leg, and I'm guessing that might be the hypotenuse. So we'll say it's 4 squared plus 3 squared is equal to 5 squared. If this is a true statement, if this is true, it is truly equal, then this is a right triangle. So 4 times 4 is 16, 3 times 3 is 9, and 5 times 5 is 25. 25 is equal to 25, then for sure, this is a right triangle. That means I have to make a decision which angle is going to be the right. In that case, it's always going to be the angle opposite of the largest side. Now let's talk about why the hypotenuse is also the largest side. When it comes to all triangles, we have special characteristics of triangles. And one of the characteristics you've learned is that all the angles inside a triangle, let's call this A, B, and C, measurement angle A plus measurement angle B plus measurement angle C all add up to a simple number of 180. 180 degrees. Now, that's something we talked about in geometry. Well, since all the angles add up to 180 degrees, well, there's a special characteristics about a right triangle. Well, if the right triangle took up 90 degrees, that means the rest of the angles must share the leftovers. Now, this is important because we also have other characteristics about triangles and angles. One thing is that if I have a small angle, look at your cute little angle. This is what we call an acute angle. The opposite side is going to be small. A small angle leads to a small side. A large angle leads to a large side. So as the angle gets larger, so does the side. Okay, small angle, small side, large angle, large side. If I give you guys an obtuse triangle here, that's a super fat angle. Look at that. That angle should go on a diet.
You want us to take notes on all of this, correct?
Yeah, whatever you feel like is necessary. And this stuff, since it's super kind of review,
review.
You're good, then fine. Yeah. But for the upcoming stuff, for sure you have to take notes.
Okay. Are we doing upcoming stuff today? Or is it all kind
this is the Pythagorean Theorem today. And we're going to go characteristics that will lead us to what we're doing.
All right, great.
Okay, so this is my fat obtuse angle. That means the side is for sure going to be large. So why is it in a right triangle that the hypotenuse is my largest side? Well, that's what we were just talking about, is that a large angle gives me a large side. Now, the 90 degree, wait, aren't all the angles inside a triangle 180 degrees? And if I took 90 degrees, I took half of the angles already. If I took half the angles, the rest of the angles are gonna have to be small angles. This has to be small then, and this has to be small. Because I took half, the leftovers, it's almost like you as the biggest brother stole all the food and the scraps are left for everyone else. So can this small angle ever be bigger than the 90 degrees? Can this angle down here ever be bigger than the 90 degrees? No. So none of these sides can be bigger than my hypotenuse. So the hypotenuse will always be largest, by just domination of the largest angle. So that's one reason why hypotenuse is always the largest, like more of a math logic reason. So whenever you're trying to figure out which one's the hypotenuse, so if I give you a triangle without drawing it out, and I give you 3 sides, here are 3 sides, is it right? If I give you a 5, 7, and 9 triangle, just to try this, would this be a right triangle? We would predict that, hey, if the Pythagorean Theorem works, then we could say this is a right triangle. But which would be C? Well, as we mentioned before, C is always the largest side because it dominates the angle, 90 degrees. So if this was true, my 9 is my C, and A and B doesn't matter. So 5 squared plus 7 squared is equal to 9 squared. 25 plus 49 is equal to 81, and that's 60, 74 equals to 81. This is not true, so this is not a right triangle. So there's some pros and cons about this. First, we have a definitive rule that states how to find a right triangle, and that we also know that if the sides change, if 2 sides of the change, the 3rd side changes. Now let's go ahead and use the application of a right triangle to find missing sides. Find the side. Okay, so we're given 2 sides of a triangle. Call this 3x, call that a right triangle, and we'll call this 8. So since it is a right, we can use Pythagorean Theorem. So we'll call it A, B, and C. So 3 squared plus x squared is equal to 8 squared. You could write x squared plus 3 squared is equal to 6, so 8 squared. You could do that. That is not a problem. The order doesn't matter for the legs. If we multiply it out, 9 plus x squared equals to 64. Subtract 9 to both sides. X squared is equal to 55. Now, most of us might have forgotten, or maybe somebody has forgotten, my next move to get rid of a square is to take a square root to both sides. So we take x is equal to a square root of 55. Some of you guys are screaming at me to add the plus and minus. Good job. Now, the reason why we're not going to use the negative sign here is, would it make sense that this side would be a negative square root of 55? A negative length? Have you guys ever seen a negative length? How tall are you? Negative 4'8". Yeah, it doesn't work. When you measure something in terms of distance or length, you can't use a negative. So that's going to not work for us. So we're only going to use the positive. Okay, so that's the logic behind it. So next thing is, can I simplify the square root? I use something what I call the box method, where I divide the number by the smallest number possible. 5 goes into 5 one time. 5 goes into 5 one time. So 5 times 11 is 55, or 55 divided by 5 is 11. And I realize these are 2 prime numbers. I don't have any pairs, so we are done. Square root of 55. Okay, to take advantage of this example that we have, I want to make sure that these 3 sides make a right triangle. We're going to use these 3 sides that we came up with to come up with a right triangle now. Let's just verify it. So a squared plus the square root of 55 squared, and we're at parentheses there, is equal to 8 squared. And you might say, Mr. Ko, that looks a little fugly, right? Square root of a square. Remember, a square and a square root essentially cancel each other out. If I say square root of 55 squared, I'm saying square root of 55 times square root of 55. Or, to talk about the algebra 1 rule, whenever you are multiplying square roots, you can write them together. I am doing this the long way, okay? I am doing this the long way so you guys can see the logic. And since I have two 55s, this is just 55. Or a square and a square root cancel each other out. That's the fastest way to do this. A square and a square root cancel out, leaving me 55. So whenever you're squaring a square root, hey, count it a blessing, because it's actually pretty fast. Oops. And 55 plus 9 is 64. So we did this correctly. I know a lot of you guys are going to ask me this question. What if I'm squaring a mixed number in a sense? What if I write 3 square root of 6? What if I square this square root where it's not all in the square root and it's not all outside? Well, let's think of this as a really basic problem. When I square something, I can write them twice. And I want you guys to be able to write things down in the most basic level, back to algebra. When you guys are stuck on something and you're not sure about a rule, I can't stress enough that if you know your basics, you can always create that rule. And in this case, if I forgot what a square and a square root do to each other, write it out. So what is 3 times 3? What is square root of 6 times square root of 6? I'm just rewriting the order, okay? So this becomes 9 times 6, which is 54. Just to talk about that, okay? A fast way for you is you square the front and you square the back. This is 9 and this is 6. And we're done. So every time you're squaring a square root, don't freak out. It's actually a pretty simple rule. If you forget, write it out. So it becomes an easy Algebra 1 problem again. Again, in case you forget. If I say 3 times square root of 2 squared, this is just 9 times 2, done. If you forget, write it out. 3 square root of 2 times 3 square root of 2. Hey, I see 2 3s. That's 9. And a square root of 2 times square root of 2, that's just regular 2. Okay, to help you guys out in case you guys forgot how to do that. Okay. So if we give you guys a problem, I give you guys 4 square root of 2, and let's write 3 square root of 6. What would my C value be, given this as a right triangle? Those look like ugly numbers. Gosh, Mr. Ko, thought we were friends. So we go and write out 3 square root of 6 squared, sorry, that looks ugly. Square root of 6 squared plus 4 square root of 2 squared equals to, don't forget to write C squared. It's not just C, it's always squaring of the side. You square the side. Okay, the front, we said that's going to be 9 times 6. The second would be 16 times 2. That's how fast this could be if you just remember the trick. Again, if you forget, write it out, not a problem. And we're left with 54 plus 32 equals the C squared. Taking my time, 50 plus 30 is 80. 4 plus 2 is 6. Hopefully you guys add front to back now. In elementary school, they teach you to add like this. And you're like, oh, this is 6 and this is 8. It's 68. It's easier for us to go front to back as adults. Say, what's 50 plus 30? That's 80. So you're thinking in your brain 80. And 4 plus 2 is 6. 86. Okay, in case some of you guys haven't started adding from front to back. Okay, we're not done yet. Imagine if this side was 86. That'd be hilarious. It would actually rip its arms off, or rip its legs off. We would square root both sides. C is equal to the square root of 86. Now we have to always simplify this radical. You must always simplify the radical. So I'm going to draw my little box method on the side. Some of you guys like using a tree. factor tree. I don't like doing that. The smallest number I can divide 86 by is 2. And then we can divide straight up. 8 divided by 2 is 4. 6 divided by 2 is 3. Numbers that divide into 43? Can't think of any. So we're done. Answer is square root of 80. Oops. Answer is square root of 86. Okay, let's just verify this was the right answer. So we're going to check this answer using our Pythagorean theorem. 3 square root of 6 squared plus 4 square root of 2 squared is equal to square root of 86 squared. Okay. So when we square a number and a square root, that's 9 times 6. And this is 16 times 2. And this, the cool part, remember a square and a square root just cancel out. That's just 86. Yeah, look at all that work. Let me get a calculator for that. Not needed. I actually like squaring square roots. So 9 times 6 is 54 plus 32. And it literally gave us what we were talking about before. Yay. This is a right triangle. We got it right.